soil, black gold. And when you think about the fact that this soil probably took hundreds of years to form, but yet it can be destroyed in a matter of seconds because of the risks to it. So what am I talking about here? Well, one of those risks is soil compaction.
Probably only 1% of our clientele actually know what tire pressure is in their equipment. When you actually ask, they don't even know, and they probably don't even know on a gauge. They'll just air it up till it looks right, and off they go to the field, not realizing that they've just either increased their efficiency or decreased their efficiency by a number they have no idea, because they never know where they started, they never know where they ended.
The next thing on gauges, don't even get me started with this. We going through the process at home on a new piece of equipment with us, new tires, and well, set the tire pressure. Well, all right, the gauge says it's 32. Let's drop it down a little bit. And I didn't quite, just had the sense that wasn't exactly right. So we went and got a different gauge, and that's the way it went. Our good gauge gave up. So let's go borrow the neighbors, because we don't have one for low pressures that's very well calibrated. So we put the neighbor's gauge on it. Well, it says it was 25. Well, we started airing the tire right back up again. Well, I just didn't think that was right, so I went to Canadian Tire and cleaned out the rack of pressure gauges. 2 of the same brand, 1 different, 1 mechanical. Took them home, checked them all. None of them agreed. Up by 3 pounds, down by 3 pounds. You know, that's a lot, and that's 10% on a 30-pound tire. So, you know, that's what, 10,000 pounds of weight carrying, or well, I mean, not 10, but it's 1,000 pounds anyways, the weight carrying capacity. So, well, what do they do on the weekend? Built a little test rig with 3 different air regulators on it and set it for 25 or 30 pounds of air, checked all the gauges. So the next thing you're going to find is your gauge is calibrated for a specific range. Some are good from 5 to 100, some are good from 0 to 10, some are good from 0 to 30. So what tool are you using? And free tip Friday, it is Friday. Yeah. Tire pressure monitoring systems at the Wally World or the Getting Spot, wherever you're going. $100. You get little valve stem caps with the secret sauce in it, and talks to the little screen in the tractor. Put one in. Like, what do you got to lose? If you got, say, duals, you got 8 tires on a 4-wheel drive tractor. Do you want to go around and check them all day long, or do you want to put 8 fancy valve stem caps on it and have it tell you, at least tell you whether it's off for $100? I've wasted $100 on something much less stupid. So.
Can we bring in the aspect of managing manure? Okay, manure is a heavy product. We know we're taking a lot of weight to the field. So some of your thoughts specific to managing manure in light of compaction. Alex, you start us off.
Just the logistics of getting it out, that's right away the problem, is because it's like going to pick up bales over the field. You got to do it. There's no way of getting around driving over to the bale. There's no way you're going to cover the whole field with a manure tank. So on 100 acres, I think it's been a few years since I do the math, so let's see whether I remember it. It was 50 miles of driving with a 4,000 gallon, well, any tank, I guess, it'd still be 50 miles, but for 4,000 gallons per acre on 100 acres, you were doing 50 miles of driving, just putting product down. So now there's 50 miles of driving, because you run the tank out, you got to drive back to the farm gate. Well, the gate's over there, so now I got a whole bunch of empty driving I got to do. That adds up quick. And then if the farm's 3 miles down the road, that's, 3 miles times 2 times the number of trips you got to make. So there's a lot of opportunity there's 100 miles at least in the field where you can be at low pressure, and then there's whatever miles you're on the road. So right away that screams CTIS, because you got 2 different situations. Or invest in the rigging to bring the manure to the field. So nurse tanks, trucks, highway tractors, they're capable of carrying weight on the highway. But that's a whole other direction you got to go. So the understanding that you can't get away from driving on the field, now think about what you're touching the field with. So what tire you have, how many axles, what's the weight on each of the axles, are they balanced? So the biggest thing, one of these spreaders, I won't say which one, the front axle on a set of tandems wasn't really helping. We were not carrying its fair weight. Have you ever carried a dresser with somebody and 3 people are lifting it with you and one guy's clearly not doing any help? What's he doing other than being in your way now? So if you're gonna have 2 axles, make sure that they're sharing the load. So, because you got to drive on it, so you might as well drive on it with something that works.
Yeah, lots of points there. Ian, anything to build on what Alex is saying?
I think the big thing to recognize is that, like, per pound of nutrient, manure is relatively expensive for the weight, but it's just such a great nutrient to have because of the ratio and the way it is. But because of its weight and stuff, the timing is so important, right? And so if you're a livestock guy, you know, you should have cereals or forages to be able to put the manure out on those crops midsummer when you're not threatened up against the wet springs and the wet falls. I think that's one of the biggest points for me.
Yeah, Kevin, thoughts on managing manure?
I think, again, the new technology in tires, so most of the new tires that are coming on the tanks are a VF-rated tire, which allow you to carry 40% less air pressure. So that extra 40% savings rate right there. And then the CTIS, that was one of the reasons PTG 30 years ago decided to get into the system, was to manage the manure haulage. There they have a little skinnier roads, so it's an even bigger problem. They can't put the big tires on it. That's
Jake?
Yeah, like it's in 2010, I think it was, that we had to access manure for our farm. So a neighbor said, "Yeah, your manure is fine, but you're wrecking my field with you're just packing it." And there was truth to it, and that's when I, excuse me, inquired about tire pressures. You know, can we lower the pressures on these tankers? And the technology wasn't here in Ontario, and we were able to go to Europe on a mission to discover that this technology existed in Europe. Came home and did put a system on from the trucking industry, but the trucking industry is a little different in agriculture just because of the size of the tires. But what we learned was there was a huge advantage to changing tire pressure on the go. And that's how AgriBrink began. But the value of the manure is so great. And on our farm, we side dress a lot of our manure into standing corn when the ground typically is quite dry. But we would never go on the field in the spring in our farm because of the weight of the equipment. And so your weight, again, is a big factor. Even with CTIS, it's a tool in the toolbox. But you cannot just say, "Hey, I got this, I can do what I want."
Yeah, it's not the whole.
It needs to be managed.
Not the whole answer. Eric, your thoughts?
I would say in a lot of applications, we know multiple passes can do a lot of damage over time. And so if there's an opportunity for you to exit a field and enter a field at either end, have different, we always call it designated travel areas, so that you can actually control traffic. If you have to do multiple passes, there's always opportunity for you to, rather than destroying your entire field, focus on what can you sacrifice and do the best job, the least amount of passes. At the end of the day, is really, it's simple math. But we just, unless we give people the knowledge that multiple passes are doing a significant amount of damage, it's hard to put a number to that sometimes. But I think people are seeing it. High travel areas are also low yielding spots in the field.
Can I add to that?
Yeah, do.
All of these guys making me think of this point. As this equipment gets bigger, it gets heavier itself, and then when you add that much more volume, the weight increases. But just because I have a 15,000 gallon manure spreader doesn't mean when the conditions are poor, I have to fill it. Absolutely, it doesn't fit in logistics and stuff like that, but just because you have it doesn't mean you need to fill it all the way. And so being able to be flexible to adjust how much you fill on each load, changing with the soil conditions, might be a thing to think about.
When you're buying a new manure spreader, so this is where size gets into it. You've seen probably a number of different sizes. So what's the 4,000 gallon, 8,000 gallon, 15,000 you got to think of your field size. So Eric's point, you have a designated travel lane on both ends. It would be my best interest to be full at one end, be empty at the other, get the rate that I wanted. So now you can get clever and you can buy a tank that's the right size, that's going to give you the application width that matches with the rest of your farm, so that I minimize my amount of extra passes or offset passes or this and that, and my volume's right for my average field length. So now, because if I have too big of a tank, I'm going to come in, I'm going to do not quite a full round or a round and then a half a round. Well, now I'm stuck in the middle of my field and I got to drive empty across the field.
Which is fine. It's the full load coming
It's
back.
the full load coming back. But, you know, travel being travel, if we're trying to reduce it, now you can get kind of clever with your manure tank size, and that all factors into your efficiency, but you save time loading it because it's not so big. And so when I say 3 loads an hour, that counts for basically any size manure tank from my math, my experience anyways. That's a pretty good day for spread manure. Now with the axle weights on the big pieces of equipment, that's where, you know, we see kind of the heavier axle weights on things. The only thing heavier is maybe a grain cart, but they don't have enough axles, and that's a tangent that I will not go on right now. But you see some of the heaviest loads on manure tanks, but from a, you know, pound per pound, pun fully intended, comparison to other pieces of equipment, they're not necessarily the worst setup for your field. We've seen some balers with, you know, big square balers with some poor selection of tires from the factory. They'll do just as much damage to the top 12 inches as a good setup manure spreader. Anything else that's got a heavy axle weight, so forage harvesters, that was a big one. And then buggies being worse again, grain buggies, and then even self-propelled sprayers, probably the biggest offender for that top 16 inches of your soil profile. And then worst of the worst, hay wagons with truck tires. Absolute worst idea. 11L tires need to go away. Don't even use them for your silo tarp and the bunk. They're not appropriate for a hay wagon scenario. But they're probably worse than any of these pieces of equipment that you see at the Manure Expo in that top 12, 16 inches. Again, keeping in mind that the weight is generating your compaction at the depth.
Other comments on manure management? Jake, I know you wanted to make some.
Okay, we had a customer call us and said, hey, I have a drag hose system, and we thought compaction was an issue because we're out there without having the big tanks out there. However, when they were planting their corn, their downforce pressure sensors showed them exactly where the drag hose tractor went, and then they put the deflation system. Because they go so very slow, they could go very low in pressure, and that really helped them out with regards to the compaction. Another thing that I'd like to mention is, so we have manure tanks, we have some massive tires, and we've seen it at the compaction days. Flotation tires are not really flotation tires unless you are able to change or have the right pressures for the application. You can have a massive tire which will not benefit you if you don't have the tire pressure at the proper setting. And I think farmers, and we all learn this, that you gotta be able to change that tire pressure, otherwise it's not a flotation tire in my opinion.
Other comments, Kevin or Eric, on just in terms of application width and practical things of managing manure? Any other thoughts there before we move on?
Well, I think it's important that as the equipment gets bigger, the wider the spread pattern, the less time you have to travel on the ground, right? And so, you know, there's a balance point there, but you err on the side of wider spread.
So wider spreader, you see it all the time with sprayers. So you get custom sprayer operator comes in with a 120-foot boom. Well, that's probably a good idea. Because if I'm working on, you need to be multiples of 3 for whatever your smallest piece of equipment is, because that'll put you on an already established wheel track. So we're talking about a piece of equipment that is probably going to cause compaction in unsure conditions. Good conditions, maybe not. Unsure conditions, probably going to be a problem. It does me no benefit to take a wider spread pattern and drive right up through the middle of my already established wheel tracks and pack a new road in the middle of my field, because now I'm just driving on money. That's what I'm kind of getting at with you got to play with your spread width, make sure it matches, so you're driving on, you know, already established stuff you've already kind of given up on from a compaction standpoint, and then play with the volume so that you can extend your distance and match that to your field. So the application width is bigger, not always better.
And so just so for people that are interested in that, Alex is referring to controlled traffic farming, where you, and so if you're looking stuff up,
pseudo controlled traffic farming. It's why would I drive right up the middle when I never have to drive there otherwise?
Yeah, just like pseudo engineering, we get it.
Yeah, I do that all the time.
Yeah. So, one other thing we haven't touched on is cover crops, okay? And we're talking about prevention, and we're talking about things that you can do proactively. And cover crops, we've seen in Ontario a tremendous increase in interest in use of cover crops. I know it's happening in the US as well. How does that tie in with compaction in terms of benefits and so on? Alex, you're chomping at the bit to start, so we'll let you start.
The next thing is, we built this driveway. If we built this driveway, what do? We get rid of all of the stuff that's going to smush out from underneath this and replace it with non-compacting fill or gravel or sand, something that drains. We put a lot of effort into making a road carry a weight. We put no effort into the field, and actually we're trying to not make our field into an engineered road, essentially. But one thing you can do is you can augment your strength of your soil by getting organic matter into the soil profile, because the organic matter is going to act like a sponge. It's going to give you some resilience or some rebound, so it'll be a little bit stronger, a little bit less prone to consolidation, which is compaction. So getting fibrous roots, all kinds. Everyone likes to ask, well, what tillage should I do, or what tillage crop should I use, a tap root or a fibrous root? I say, why not both? If you were going to refinish a car, you wouldn't use all the same kind of paint. You're going to use a primer, you're going to use a top coat, you're going to use a clear coat, or a sealer. And those are three different products that are doing three different jobs, but you put them together, you can make a nice looking piece of gear. So now you take your cover crop regime and you start to think of that from a soil health and soil strength standpoint. Now tie that into the picture. So now I can go talk myself out of all the equipment I just bought, because now I have stronger soil. So now it changes everything. So the easiest thing is to do nothing, because it takes no effort. But you know, this is also a factor in the situation that you got to account for where you're going to spend your money.
Right on. Margaret, some comments in terms of cover crops.
So there's lots of opportunities for cover crops. Like there's lots of conservation authorities that will help you fund those cover crops. The programs we deliver at Soil and Crop will help you fund those for sure. I think you need to talk to people and figure out what you can manage, right? It's like everything else. We don't all have the same tolerance for seeing that crop bolt in the spring and, oh my God, what am I going to do to manage it? So it takes a little bit of work to figure that out. And I guess the other thing that this whole prevention part, I'm not convinced we can prevent it. I think we can try and learn to live with the compaction that we inflict, or try and inflict as little as possible. But by remediating your soils with cover crops, with manures, with the right tire pressures, I think you'll do a better job. But you first have to know what you've got to start with.
Yeah, excellent. You guys, Jake?
So on our farm, we've gone to strip tilling, and the reason we strip till is we like to have that we never drive where we plant our crop. So there's no compaction or zero compaction where that plant goes. But also what we do is in the fall for corn or after wheat is we'll put our manure down at 30-inch rows, and we'll put oats in there. So we'll have oats grow as a cover crop right in that strip where the corn will be planted the following year. And we use that as a cover crop. So we're trying to keep the structure of soil as much as possible without doing any tillage as least as possible, and then we use the cover crops as well. So it's a package deal. It's not just one thing that you can work with.
And that leads in nicely to the farm that we're on right now, Mapleview Farms. And maybe we'll jump down to the soil pit and we'll take a look, because we've dug a soil pit here. We've gone down 3 feet, and we can show you the horizons we have there. And you'll see Alex there along with our colleague Jim Warren talking about the soil on this particular farm, which they manage currently through a minimum tillage system. And you can see the historic tillage in the soil. So let's jump down to the soil pit though now and take a look.
All right, so down here in the soil pit, joined by my colleague Jim Warren. He's gonna kind of tell us the geological history of the land that we're playing around on today. As far as finding compacted areas of your field, this is my go-to. You can build these at home. There's nothing magic. Piece of steel, weld a little tip on the end, and then just walk around your field and lean on it. Obviously, I'm well down into the soil profile here. Just lean on it. You don't have to try to bend it or anything, and just get a feel, sort of get that steering wheel feedback of your field in a few different spots. So I like to go probably over to the fence bottom, maybe under those trees, and see kind of what the undisturbed natural compaction situation is, and then come out into some areas that you might be questioning. So wheel tracks, good place to check. Middle of the undriven areas of the field, see what's going on there. And I can put this tile probe into the ground fairly decently far all over. I tried it in a wheel track, I tried it in between. Other than the general stoniness, I'd say in these conditions probably pretty okay. No, what I'm looking for is real drastic changes in sort of force required. So that's going to tell me I've kind of got a layer probably of some denser soil. But what I was finding, Jim, I could bury this about that far into the ground, and that lines up pretty well with a horizon that you've established here. So what do you think's going on there?
Well, could be any number of things. Actually, this is a more or less a clay loam-based soil, so fairly fine textured, and you'd expect a little bit of water impedance, and possibly the stuff is fairly easy to compact just because it's a clay. What you're probably running into there is the sea horizon at the bottom, which is the native parent material of the soil here. I guess that's kind of natural, because as you go down, your bulk density will increase. But you got to watch out for, I would think, again, not being the compaction expert, but the clay here is the one where you got to watch that you get subsurface compaction just because that clay is there.
Yeah, and that ties into sort of the axle weight story that I was talking about earlier. So most light pieces of equipment, I say light, like lighter axle weights, but higher pressure tires, maybe poorer selected tires, you're really going to see the effect, in this topsoil layer. And this is what you're immediately going to see in your crop. You're going to see, wheel track damage or emergence issues where you've driven inside of the ear in that crop condition. But the long-term effects from that deep compaction, those are harder to spot and harder to diagnose. But over in the soil pits where I had the sensors installed, I was at a sensor at 6, 12, and 20 inches, so roughly at these depths, if you want to picture that, and measuring the sort of the confinement pressure, or the squeezing force that vehicle is putting on the soil as it traverses. So if you can imagine, what's the force being squeezed onto this golf tee, that's what I'm measuring. We were getting, high pressures here, reasonably high pressures here. It's going to be lower as that pressure zone distributes into the soil. And then we hit this massive block of clay, Jim. And my sensor would just be inside of that clay region. And we weren't hardly picking up any stress at all. With the heavier pieces of equipment, heavier axle loads, we were just starting to see that pressure bulb just kind of reach down to that layer about 1 and 2 or 3 psi. And that really tells me in this soil, this is a really good structure right now, and it's the conditions are appropriate. I would say. Not too much water. We did have a dry area and a wetter area. We had put some simulated rainfall on the area where we had the sensors installed, and you can see a pretty significant difference in the amount of stress. Lower stress levels in the drier pit than in the wetter pit, and that's due to this. What I'm thinking is this top layer. There's a significant amount of organic matter in it.
Yeah, there is. I expect actually it's going to be actually a little higher in the top. According to the producers here, the soil hasn't seen a plow, a moldboard plow in 25 years.
Oh, really?
Yeah. So you can see it marked at AP1, AP2. So this is their cultivated layer right now.
Oh yeah, I can see that little bit of a shelf carved out here. Yeah.
This area below probably hasn't seen sunlight in 25 years.
Oh really?
Yeah.
So
So the original plow layer would have been down to here when they were plowing moldboard, and now with their light tillage or whatever management system they're using, they're only really touching the surface, and that's it.
that's interesting. So the rule of thumb for soils: a 1% organic matter for every 5% clay content. That's going to give you a really resilient or a strong soil for load bearing. So I think Jim came up with a number around 3.5%, 4%.
4%, something like that.
We're somewhere in the clay loam region,
Yep.
you say.
Yep.
So we're flirting with the ballpark there, and we're in that region, and that really agrees with what I've been seeing over at the soil sensors. Not too high stresses from what we've seen on other soil types and other wetness conditions. So overall here, a pretty strong soil, able to handle a lot of these weights that we're throwing at it. One thing that's also interesting is this sort of mixed layer of, would you call that kind of a sand? Well, it looks like there's some sand in it.
It is. There's a little more sand in it. It's actually an interesting area. I've got it labeled here as a BTGJ. There's actually two of them. If you want to see it, one here, the surface of a 1 and a 2. You can see the difference, obviously, in the structure. Probably a little more sand for whatever reason, but in the till, that's to be normal. It's just that everything and anything can be mixed into it.
Right.
This is also influenced, though, by, you can see the root runs and
Yeah, I see that.
and
There
the
was a
worm
really anxious worm here trying to get all the way down to the
you
CKGJ.
can't see them now, but there's actually wormholes actually on the stuff we're standing on.
We saw that when we were digging it. Now I'm poking holes in it with my little tile probe here, but the worms can get that deep, surprisingly enough. So,
Yeah, even in this stuff.
speaking of drainage, maybe you can kind of enlighten us here. But how would you expect water to move through this profile?
Through this profile?
Yeah.
Okay, well, typically it will, of course, land on the surface, run through with the major pores, and then your only way that the water is going to get anywhere through this is primarily to be released quickly through the larger root runs as well, or the wormholes, either one. This is actually an imperfectly drained soil, because you can see the actual models here. So the groundwater has come up, or was up here and purging on this area at one time. The site now is tile drained, so you don't see as much water coming up as it used to. But anyway, the main thing is you're going to get a perching, like a minor perching first after a good rain, and then it will run through those cracks. The more of those cracks you can actually get, or those flow systems you can get,
So
for drainage is better.
worms in this sense are adding quite a bit of drainage to our imperfectly drained profile.
Absolutely.
Now, if I was to come in here during a wetter year, say I had a lot more moisture in this profile, and I was seeing, high stresses that we would, maybe be able to measure in this region, I would expect to see some consolidation. How do you think that would affect soil water movement again?
Well, the consolidation is going to actually close up all those pores, so you won't have as many large pores to drain the water as quickly.
Yeah.
So any compaction that's going to happen that'll be the larger pores will be the one that disappear first.
And the other thing there, now if I compact this layer, and this would be a relatively compactable layer, there's under the right wetness conditions, I would expect to be able to make a very good road out of that soil, or a good driveway at least. Maybe not an actual Queens Ontario road highway, but if I was to consolidate this layer, now I'm just severely limiting the water that can get away from this upper region and the water that can come up from the bottom. Understanding this field is tile drained, so I'm not going to get a lot of water up through my profile, but I do want it to get at least into the rooting zone, so my crops can get to it.
Yeah, so the roots will try and get down there, and as you can see, they've in some
They're
cases
doing their
succeeded.
best.
Succeeded,
Some
yeah.
of them have followed that wormhole all the way down. So, and that was the case. We found a lot of fibrous roots in the bottom of this soil pit when we dug it last night. So.
Yeah, there are a few. Not that one.
So that's the.
There are some roots in there. I don't know if you can see that, but
There you go.
that's from that's C.
That's the sea horizon.
Yes.
Yeah. Some structure,
Some,
but
not a lot.
not a lot of structure.
But it's there.
Oh, very interesting. So yeah, there's your soil profile. That kind of puts I kind of put the sensors in blind when I go to a site, and then I usually get to open the present afterwards, so I get to see what kind of stresses we're seeing under the equipment. And then when I go to dig the sensors out, I really see what kind of profile we were in. That's the trouble with doing sort of in situ measurements with undisturbed soil is I don't know how to reinterpret the results until I kind of can close the loop on what the soil profile looks like, and this really kind of clarifies what kind of pressures we were seeing over there. An interesting thing, didn't see it on this site, but with the sensors on a different location, we were seeing really high stresses at depth, and it just so happened that when I put my sensor in, I was in a really defined lens of sand, wet beach sand almost. It was just bizarre, but that meant that whole sort of mat of soil on top was floating on this kind of wet sand layer, and that just threw me the whole time. I thought my sensor setup was poorly installed, and I couldn't figure out why I was getting this weird reading at depth. But until I opened the profile to see what was going on, and I happened to be right in that sand lens, that really told me the whole story. So you can go around with a stick and kind of get a feel for it, but if you got nothing to do on a Sunday, go out and dig a hole in your field and see what you're playing with. And then you can read some of Jim's lovely bedtime reading that he's put together, and all the soil series for the province.
It's good bedtime reading.
It's interesting. Once you get into it, you can really start to peel the layers of the onion off, and it does eventually get interesting. So.
Glad you think so. That's good.
So thanks, Jim. We'll head back up to the barn and kind of cap things off.
So you've seen the soil pit and heard a bit about the actual soil conditions here on this farm. And this farm, they are cover crop users. They use cover crops regularly. In fact, the wheat has just come off and they've got machines in the field putting cover crops down today. But let's talk a little bit more about that. Ian, some other thoughts on cover crops?
So if we just think about what is the platform that we're taking heavy equipment out to use, the best one is a living crop. The best one is probably a perennial living crop, so on forages, right? That ground can take the weight better than others. Putting it on living cover crops is better than putting it on residue like from the wheat harvest, because again, those living root systems are there helping you. All that breaks down as you till the soil, right? And so the worst case is tilled soil, because we've disrupted the soil strength and aggregation, as Alex was alluding to at the beginning. And then as you take tillage out and you add living plants into the equation, then you're in better situation for the soil to take the weight. You still have to be cognizant of is the soil fit, but that gradation improves as you get more living crops and less tillage in your system. I'd be interested in other comments.
So that's the next thing you can think of when you're working in a cover crop strategy, is the timing of when you get that cover crop established, and if you're going to then drive on it. So say if your field's underseeded with clover, we took wheat off last week and the clover grew probably 3 or 4 inches in 2 days. Like once that crop was gone, time to go. Now we can drive on that, and we've got a cover crop already established, right ready for manure application to come in. So getting the timing tuned You can do something similar in corn, say putting inner seeding or eye into corn. Once the corn silage comes off, now you got something to drive on. It's already there. So, you know, now you're starting to get into the minutia of all these little buttons and knobs you can turn to find the right strategy for your farm to work with the equipment that you have, just to really optimize everything.
Eric, you got some thoughts on that? Now I know you have Alex speaking right into your ear.
I'm a little sore on this side.
Anything you want to add on the cover crops?
It's interesting. I've been kind of monitoring that in the last 10 years. There's been a lot more of that because I think the general populace has seen the advantages of cover crops. I remember when it was kind of looked at oddly that you had a cover crop and, you know, you're kind of a weirdo, you know, to grow a cover crop. Now it's like they have those years of experience and also years of behind them of running cover crops, and now people are starting to see the advantages of that soil structure, and they are actually, you know, 5-6 years ahead of the average Joe Blow that hasn't even applied himself to exploring that option. So I think, you know what, it always takes time to really bring something into fruition when we're talking soil health and structure, and once we have seen something get established and it works, it'll take you a lot longer to get there because you're only starting now. But I think people are seeing the payback, and that's why we're seeing more of it being done.
Yeah. Kevin or Jake?
A little bit, I guess tires were always trying to reduce the amount of erosion, and with the cover crops, it's really managed to reduce the erosion a lot more.
Yep, right on.
I think the more we start to realize about soil, the more we realize how little we know and how much more we need to learn about the biology in the soil. And I think that's a really big subject, big part of the soil health. And again, a compaction is a big part of that whole equation as well.
I think that's a great point, is that fundamentally you realize that we are inflicting a mechanical process on a living system. And sometimes we forget about the soil as a living system, but it is a living system, and it's going to respond and react to the things that we do to it, and so we've got to treat it like a living system and manage it that way. So as we go into some final comments here, I just want to give each of you a chance to kind of give your, if there was either one thing that I'd like to see changed or happen, or one comment I'd like to emphasize, I'm going to give you the chance to say that. And Margaret, we're going to start with you.
I'm going to take two. I want you all to do an environmental farm plan, and I would like everybody to be able to weigh their equipment to know what their axle weights are.
Right on. Kevin?
Mine is similar to Margaret's. There's lots of opportunity to have your equipment weighed, set the air pressure, and have the proper tires underneath it.
Right on.
That'll go a long way.
Yep.
I always think history is an important thing to know. We look back and say, how come those people did what they did back then? Did they have their eyes open? What are we doing today that in the future someone's going to say, how come you guys did that? Why weren't you more aware of what you're doing? And I think that the compaction is a huge topic today, and I think we cannot just turn it aside and say, well, you know, it'll go away, or it's going to only get worse.
Ian?
You know, compaction is complex, and there's a lot of pieces in it. And we as a group here, as a partnership in this Ontario Compaction team, we're trying to help people have that information available to them. And so I guess I'm asking people to look for good information to educate yourselves on how to improve your performance around manure management and compaction to your benefit.
Eric?
I always say knowledge is great, but wrong knowledge is worse than no knowledge. And therefore my focus as a business tire retailer is to make sure the information that our team brings to the table is correct, is what is real life data, so that when you go home and use it, you see the results that we are expecting. And so therefore, that knowledge doesn't happen by itself. It takes a lot of time experimenting on our own time, doing our own little projects, so that we can actually get real life data to our farmers and say, when they leave the shop, we say this is our expectations. We know already 100% it's going to be that way. We've done our homework. We know it's going to work. It's not a guesswork anymore. So,
Awesome. Alex?
Just what I would say is you've got a whole bunch of new tools. Don't try to just shoehorn one thing into a system, because at the end of the day, you're a cash crop farmer or a livestock farmer, or you still have day-to-day activities that need to get done. If you try to shoehorn another project or chore in between an already established calendar program, it needs to make sense and be worth your time. So go out, buy CATIS, and then put no effort into managing it, using it effectively. That's not going to do you any good. Or wholesale changing, say, your manure application regime. Well, it's got to still work with your existing barn. It's got to work with your existing manure handling equipment. It all, you're kind of painted into your own box. There's no way you can just change the whole box at once without spending a whole outset of cash. So the little pieces have to work for you, and just because it works for your neighbor's situation doesn't mean it's a home run on your farm.
So I appreciate all your final comments, but Ian has to have an ultimate comment. Ian.
Well, Eric said a very important thing about the data, right? And so we are out here doing something on this farm, on this day, on this year. And so as we've done these different compaction and manure days, we've been doing sort of points in time. So it's valuable information, but it may not be the perfect thing for each situation. It gives people some guidance into what they should be looking at, but it's important to consider your own situation and find the right people, like the people around the group here and others, that can help you come to the solution for your farm.
Those are excellent notes to finish on, and let me just say thank you to this team here. You're seeing them for a few minutes, and you're going to get some clips of the work out in the field with the sensors. I've seen the work that they have done, the time that it takes to install sensors in the ground, to run the equipment over, get everything done. They've been here for 3 days, and they've done that at many other events. So I want to say on behalf of Ontario Agriculture, thank you to each one of you for the work, for the time. It's important what you do. It's making a difference. And I know that you're not saying, here's the answers. You're saying, we're on a journey. And here's what we've learned, and we have much more to learn. So in finishing, I invite you to come and learn with this team as we continue this compaction journey. Thank you very much.